right, and here's the rest of the IEEE TWIOS sessions, stands for Topical Workshop Internet of Space, and this was in January of 2018. TWIOS Session 1 had a theme of next generation concepts for space, and it was chaired by Charlie Jackson from Northrop Grumman and Thomas Usmüller from the University of Innsbruck. If you've been hanging out with us for a while, then you know we have already attended an entire class about commercial airline backhauls, so we skipped this one and had a civilized breakfast instead. This application is entirely commercial and locked down and follows the design patterns of the subscriber or receiver being the entity that's very carefully controlled. We're already doing everything right in this implementation that we can be doing that we know about. Now, as you know, in amateur radio, the receiver isn't the thing that we are controlling, it's the transmitter. Anyone can receive, but we have only licensed transmitters. This is somewhat of a reversal of some of the assumptions, and it means working through and adapting communication protocols very interesting and rewarding. TWIOS Session 1, Talk 2 was a compelling and meaningful application of satellite communications links supporting a vital infrastructure project to a very marginalized and overlooked community in the Himalayas. The remote monitoring is for a small hydroelectric plant. The lessons learned here are very relevant. Maintenance, ease of use, pay-as-you-go, sustainable and durable design, listening to the community, and understanding what they really need. This came through loud and clear. The satellite technology in this case was a very small part of the presentation. The point of this talk was to show how satellite communications can provide remote monitoring and Internet of Things support. TWIOS Session 1 Talk 3 was very relevant to Phase 4 space. Design challenges of a highly integrated SDR platform for multi-band spacecraft applications in radiation environments by Jay Budravite and his team from Brandenburg University of Technology. Guess what they did? They took the AD9361, which is the same RF IC used in the EDIS USRP 300 series, and they zapped the snot out of it with radiation. They also got results for the voltage regulators. Voltage regulators are a hard part. As radiation goes up, voltage goes up, things stop working. So, to quote, at a total ionizing dose of 7.5 kilorad, the regulator output voltage in these tests increased continuously until the voltage level reached the maximum specified input voltage of the following powered devices. Other sub-voltage regulators in the system show similar ionization effects behavior and has been classified as medium critical for further development activities. So that's the voltage regulators. Okay, everyone in our circle pretty much knows that the 7000 series zinc processors are going to work out as radiation-tolerant devices, but characterizing the RFIC was something on our radar, and Brandenburg University delivered. The result? For the RFIC at a dose of 17.5 Krad, the test setup was modified with shielding blocks for continuous irradiation only for the RF transceiver part. The AD9361 showed good robustness against this ionizing dose. No degradations were observed. How cool is that? Oh, and then they amped it up to 25 Krad and it still didn't care. The goal of his team is to put a highly integrated general SDR platform for multi-band RF applications in space using a state-of-the-art transceiver. In-orbit verification is expected on the S2 TEP launch in 2019, with testing in early 2020. This is a 35 kilogram microsat. Well, this is right up our careful COTS alley on Phase 4 space. If you want to help, write me and let's use these results to get a design together. TWIOS Session 2 in the afternoon was Radiation Considerations for Space, chaired by Thomas Usmüller from the University of Innsbruck and Charlie Jackson from Northrop Grumman. TWIOS Session 2 Talk 1 was a circuit design for a radiation-tolerant 2.4 GHz synthesizer based on COTS components. Motivation is the move away from large, bulky satellites to commercial commodity smaller satellites like CubeSats. This move has increased the use of Wi-Fi. Commercial wireless technology in space needs a good synthesizer that is radiation tolerant, and the design discussed here is a more durable synthesizer built up from discrete, carefully chosen COTS components. There's a lot of careful COTS discussed at this conference. If you're not familiar with that term, it means that you construct your circuit from radiation-tolerant commercial off-the-shelf components that were not specifically designed for space, and then you test your design at the system level, possibly putting in lots of redundancy and other mechanisms to recover from radiation-induced events. Careful COTS is in contrast to the much more rigorous and expensive designed for space from the beginning, heavily integrated solution that we call radiation hardened. This synthesizer isn't terribly high performance, but it works. TWIOS Session 2 Talk 2 was about JICG MOS transistors for reduction of radiation effects in CMOS. This is manipulating things at the silicon level, so not exactly in our ballpark yet. TWIOS Session 2 Talk 3 was reflectionless filters for miniaturized space applications. This is a class of filters that are very small, therefore possibly of use in CubeSats. Inductors don't obey Moore's law, according to the speaker, it turns out, so some circuits can be miniaturized much more easily than others.